Hallucinations manifest the formation of parasitic event memories. This notion has implications for understanding the pathophysiology of schizophrenia. Event memories are complex representations of objects or events in their context. Sequences of event memories can be recalled as episodic memory. Episodic memory functions depend on the ability of the hippocampus to conjunctively encode arbitrary objects, features, and their context. Consciousness too combines various facets of information into a unitary representation. The content of consciousness is reportable and is recorded, at least for the very short term. The stream of consciousness consists of discrete events. Iconic memory is suggested to be an event memory that has just been formed but not yet consolidated. Conscious awareness of the external world would reflect the ongoing process of event memory formation. Correspondingly, conscious imagery manifests event memory recombination and recall. Cono-ammonis region 3 of the hippocampus combines arbitrary object and contextual information processed in parietal and temporal association cortices and received via the entorhinal cortex. Entorhinal projections to CA3 are characterized by a high degree of convergence. CA3 pyramidal cells are extensively interconnected and form a single autoassociation network. Activity patterns forming in CA3 settle into an attractor state at each cycle of the local theta oscillation. These patterns are encoded as event memories. Their encoding depends on temporal convergence of gamma frequency input from the entorhinal cortex and local theta oscillations. Thus, theta oscillations in CA3 help to ensure the continuous gathering of information about the environment. Not only event memory formation, but also recall is implemented by associative pattern formation in CA3. These processes manifest as conscious perception and imagery. Hallucinations are not fundamentally different from conscious perceptions. Whilst CA3 pattern formation is arguably the neural correlate of consciousness, aberrant pattern formation in CA3 would be the neural correlate of hallucinations. In patients with schizophrenia, hippocampal volume is often reduced and episodic memory functions are impaired. In functional imaging studies, there is reduced task-related activation of the hippocampus. However, hippocampal baseline activity tends to be increased. Baseline hyperactivity of the hippocampus is associated with a tendency to experience hallucinations. The actual experience of hallucinations is accompanied by an increase in hippocampal activity. Neuronal excitability is increased particularly in region CA3, which predisposes to aberrant event memory formation. Hyperactivity of pyramidal cells in CA3 can have different causes. Firstly, there is evidence for loss of fast-firing basket cells, which normally restrain pyramidal cells. This in turn may be due to excitotoxicity resulting from excessive glutamatergic input from the amygdala. Secondly, decreased function of NMDA receptors on basket cells would cause pyramidal cell overexcitability. Another cause of CA3 pyramidal cell hyperactivity is weak glutamatergic input from the dentate gyrus. Hallucinations would be a direct consequence of excessive pyramidal cell firing in CA3. Indirect consequences are firstly activation of the ventral tegmental area via a multisynaptic pathway causing a hyperdopaminergic state, and secondly activation of the medial prefrontal cortex, again with associated behavior abnormalities. CA3 pattern formation may be under-constrained by neocortical sensory processing for reasons other than intrinsic CA3 hyperactivity. There is evidence for decreased resting state connectivity between neocortical regions and the hippocampus. For instance, hallucinations have been related to deactivation in the parahippocampal gyrus, which links association areas with the hippocampus. Finally, activity in thalamocortical systems concerned with higher order sensory processing may in itself be under-constrained by peripheral sensory input.